Welcome everyone. So in this session we will discuss about what is device driver, what is the role of device driver in an operating system, and what are different types of device driver. And then we will discuss what is the need of device drivers. So device driver is a block of code, or we can say a software interface which control hardware and make hardware works. From user point of view, device driver is like a black box and user don't have to bother about complexity of the hardware because that is totally hidden from the user. You take example of USB drive connected to the system. We use pen drive for transferring the data between our PC and the USB so that we can save the data and we can move the data from one PC to another PC. From the user point of view, it's very easy. You connect the USB, you transfer the data to the USB, and then you remove the USB, and then you plug in USB to other machine, and then you copy the data to the different machine. So user don't have to worry about how the data is being copied from PC to the USB, how the data is being copied from USB to the PC, how exactly that transmission of data is being handled, and how USB is actually working. So user don't need to worry about all these. So there should be some program or there should be somebody who should take care of this complexity. So Linux device driver, or we can say the device driver of that particular device, take all that pain of managing and controlling that particular device so that it can be used by user in a very simple and easy way. So we can say device driver basically abstract the complexity of hardware or the device from the user. And device driver is an interface between user application and the hardware. So user application request to the device driver for any interaction to the hardware. So what happen, like whenever you are trying to access any device, let's say camera, or let's say audio or display, or let's say USB device. So what happen is, like whenever you are double clicking on the USB disk drive created in your PC, so that application, basically that user space application, request to the respective device driver of USB for opening of that USB directory and showing the data which is there in the USB drive. Or when you are using the camera, you are having a camera, when you are basically opening the camera applications, so that application is basically requesting your camera sensor or the camera driver to open the camera sensor and start capturing the pictures. So this doesn't happen so straightforward. There are different layers of code involved in it, but to give you an higher level understanding, I'm just explaining all these example to you. So users application basically request to the device driver, okay, I want to use this particular device. So then device driver basically check whether the application who is requesting this device, they have they have authorization to access this particular device or not. If they have, then they will grant the access. If they don't have the authorization, they will basically deny the access to access that particular hardware or device. This is the diagram you can see here. This is some application XYZ running in the system, and this is the device driver layer. So application basically sends request to the device driver, and then device driver will see and forward this request to the hardware. Then hardware basically respond to the request which is made by the application. So it will respond to the request of device driver to the device driver, and then device driver further moves that response to the application. So this is how this communication happens between the application and the hardware. So now we have to understand the role of device driver in the operating system. But Prior to understanding the role of device driver in an operating system or basically in the Linux, we have to understand one thing. In Linux, basically every device connected in the system is a file, is a device file. We basically call it device file. Let's say you have a hard disk connected into the system. So your hard disk will also mount under the dev directory slash dev directory in Linux kernel. So that USB device or that hard disk device will create will be treated as a device file under the slash dev directory in the Linux. Maybe we'll discuss the same about in some other session in detail so that you will have a clear understanding of device files. So each devices in the Linux is treated as a device file connected in the system under the slash dev directory. So now let's understand the role of device driver in operating system and mostly in the Linux. So as I mentioned in the Linux kernel, we have system call interface on all of the subsystem of Linux kernel. Then in Linux kernel, as I mentioned earlier in the previous session, we have different subsystem, process management, memory management, file system, device control, networking. So these all are the kernel subsystem. And then we have architecture dependent code, as I mentioned in the previous session as well. So architecture dependent code is the piece of code which is written for specific hardwares or specific architecture, let's say ARM architecture, Exynos architecture, or XYZ architecture. Then we have memory manager basically. Memory manager, like in an operating system, we have to translate the addresses from virtual addresses to the physical addresses. Then we have memory manager which take cares of all this pain of managing the memory available in the system. Then you can see here we have different devices connected into the system. We have CPU. So CPU will be handled by both the architecture dependent code. It's ARM based CPU or Intel based CPU or Exynos based CPU. Memory is managed by, as I said, like memory manager. Then we have disk and CDs connected to the system. We have console connected to the system. We have network interfaces connected with the system. So if you see, we have different devices connected into the system. So as I mentioned in the previous slide, to handle each hardware device connected into a system, we need a device driver to control that particular device. So for CD and disk, we have driver present here in the Linux kernel. And then for consoles, we have character-based device driver present here in the Linux kernel. And for the network interfaces, we have network subsystem and the respective drivers present here in the Linux kernel. Don't worry about what are character driver, what are network driver, what are block driver. We will discuss the same in coming slide. So we can say in the lower layer of Linux kernel, we have device driver present in the system, which basically enable Linux kernel to interact with the devices and which further enables user space application to access the devices connected into the system. Because device driver is like a manager or we can say the owner of the devices which actually knows in and out of the device, and device driver know how to manage the device connected into the system. So for camera you have camera driver, for audio you have audio driver, for display you have display driver. So these all are piece of code written to manage their respective devices. So now the need of device drivers. What is the need of device driver? So the first need of device driver is like, let's say you have got a USB disk or USB drive or USB or camera or any other XYZ device, and let's say there is no device driver present in the system or in the market. So do you think you will connect the device into the system, you will connect the USB into the system, and you will start copying the memory into that USB disk. You will not be able to do that until unless the driver for that particular USB is installed in your system. So that's why you must have seen, like, whenever you're connecting the USB disk to your system first scan your device and install the respective driver of that particular device, so that you will be able to access the device. Till the time your driver is not installed, you are not at all able to access that particular device. Let's assume we don't have device driver present for that particular system, or there is no device driver present of that particular device. So what will happen? We will not be able to use the that particular device. Or if you want to use that, then before using that USB device, we have to first understand the complexity of that device. We have to go through the schematic specs of that particular device. Then we have to write a piece of code or program for accessing that device. So that's all pain. Nobody will be able to take it, because not the every user is technical user or has a technical capability to do that. So this problem is solved by the device driver. So device driver is a piece of code which is already have capability to manage that device. So from the user what has to do is they has to only install the device driver, or they have to only load the device driver into the operating system. After that, your device is ready to be used. So where is the need of writing a device driver basically? So whenever there is new hardware available in the market, let's say some XYZ company started launching new camera or new camera sensor ABC, for which there is no hardware, or sorry, there is no device driver till now. So in that case, you basically need to write the device driver first, so that that device can be used by the user. And there might be scenario in which there are new feature being added to the hardware. So let's say there was a camera company, they has written a camera sensor driver for one of their camera sensor, and that camera sensor previously it was supporting 5 megapixel. Now they have increased the capability, or they have enhanced the capability of that particular camera sensor to 12 megapixel. So obviously your device driver also has to do the respective change to enable your device driver for making a benefit of that 12 megapixel. So in that case also, device driver developer has to modify the driver code to enhance the features supported by new device. So these are the scenario in which there is a need of writing a device driver or modifying a device driver in the practical world. So now, depending upon type of devices, we have type of driver as well. So now first understand what are the mainly types of devices. So depending upon the how data is being transmitted between device to the host machine and from the host machine to the device, we divide devices into three types. So the first type is character devices. Character devices are the devices in which data is being transmitted between your device and your machine or your system in character by character. So you can take example, you have serial port, you have camera sensor, you have parallel port, etc. Then we have block device. Block devices are the device in which data being transmitted in a blocks or the chunks of data being transmitted at a time. Example of these are CD-ROM, hard disk. These are the example of block devices. Then you have network devices. The devices which are basically used for network related things, that are the network devices which take care of data transmissions over the network. You can take example of NIC, you can take example of Ethernet card. So all these are network devices. And then depending upon these type of devices, we divide the driver into three parts. So first part is character driver. Character driver are the driver which manages or control the character devices. Then we have block driver. Block driver is basically a piece of code or the driver which basically manage the block devices. Let's say for HDD, whatever the driver it will be a block driver. Then we have network driver. Network driver basically are the driver which basically manage network devices. So that's all different types of devices and the drivers. So during this training, we will basically focus upon character based driver because 80 to 90% of the devices use character based mechanism for transmissions of data. So if you have any question, you can just write us a mail. Thanks for listening.